Today I'm going to talk to you a little bit about file permissions on Linux. This is actually a very key concept. It's part of the power behind the Linux operating system, and you can actually create quite, we'll call it granular profile for files, so that those who need to access the information can, while prohibiting anyone else from accessing. So it's a security feature that makes Linux very powerful. So there are basically three kinds of permission. That being read, write, and execute. And you should remember these from seeing the output of the long listing in other assignments and other occasions when you've worked at the command line. Here is an example you see from the etc password file. We see there's a long listing, and there are groups of permissions. And in this case, it's RW and then a dash, R dash dash, and then again R dash dash. They're in groups of 3. So you have 3 groups, each of which with 3 permissions. We call this first group that for the user, the second that for the group, and the third describes others. We can look a little more deeply using the etc password file as our example and see the highlights in the PowerPoint here. We have the user mask highlighted in yellow that shows R, W, and dash, indicating that the user owner of this file, which we can see is root, has read and write permission for the file passwd in the etc directory. Moving over to the next set of 3, we see the permission mask for the group. The group is also root, the name of the group, and anyone that is in the group named root has read access for this file. And we will move on and see that the third triplet is representing others. So sometimes people call this the world. Everyone else is in this group, and those accounts also have read-only permission for the etc password file. The ability to change the permission mask on a given file can be done through one of 2 methods. We'll call those the symbolic method and the absolute method. The symbolic method is accomplished through a set of symbolic characters, and then along with a directive to add or take away a specific permission. We'll look at an example or 2 to make that more clear. And then the absolute method, which we'll look at after we finish symbolic, is based on a numeric identifier, which in sort of one act will impress upon a file an exact permission. Absolutely. So the difference between when you would use one or the other somewhat depends on what you've been instructed to do, or what your intentions are. So the symbolic method is relative, which means whatever the current permission mask happens to be, you're going to modify from that starting point. Whereas the absolute method doesn't really care at all about what exists right now. It's just going to stamp upon the file this new directive. So if you don't know the current permission mask, then you would probably be choosing the absolute method, because you wouldn't know what you were starting from. But if you knew what existed now, and then just were aware that you wanted to add read permission or take away write permission for the group, then that would be a relative change, and that would lead us to be using the symbolic method. So let's look at some of the details. The command to use in either case is chmod. Some people pronounce that chmod or change mode. And the characters which indicate the groups, that of user, group, or others, is U for the user owner, G for the group owner, O for others, or a shorthand A, which means all of them together. So if I would like to add read permission for everyone across the board, the user owner, the group owner, and others, then I could use this shorthand of A to accomplish that. And then we need to add to that group what it is we want to modify, or how we want to modify. So the indicator is going to be a plus sign for adding a permission, a minus sign for taking it away, or the equal sign for making the permission exactly as specified. And then the last part of the command is the permission to confer, where R is read, W is write, and X is execute. So that should be natural for you to remember, because those are the symbols that we see when we do the ls -L command. That is what we see on the command line. So let's look at a command line, and we'll see some things that are in my user account's home directory. We have a file here, welcome.txt. That's the one I'll look at today. It is owned by the NOS 120 user. The group owner is named NOS 120. And we can see that the user owner has read and write permission. The group owner, which is defined by the second set of 3, has read permission, and so does others, or the world. Okay. So if I wanted to add write permission for anyone in the NOS 120 group, that would be the group would be the grouping that I wanted to confer a privilege on. I would want to add, and I would want to add write in this case. And then I give the name of the file that I am employing this command on. So now, let's take a look at the new mask, and indeed, for the group, which is the second set of 3, I now have write permission as well as read permission for the group. Let's take a look at another example. This time I'm going to use the file now.sh, which I'll cat out for you just so that you can see the contents. It is a very simplistic shell script which gets a formatted, uses the date command to get a formatted time, stores that into a variable that I named just simply lowercase t, and then echoes out to the screen. The time right now is $T. Remember, you put the dollar in front of the variable name to see the contents of the variable. You also can see from the long listing that right now this script doesn't have execute permission. So I can use the chmod or chmod command to confer execute permission for either only the user owner, the group, others, or all 3. Let's confer for all 3. So that would be A for all, and then add execute permission for now.sh. Now if we take a look at now.sh with the long listing, we will see that all 3 of those groupings have the execute permission. Now, let's consider the fact that I jumped the gun on that one. I acted too soon. I really didn't want to give execute permission to the world, to others. So I can again use the chmod command to take away some permissions. So this is relative to the permission mask that exists right now. So if I wanted to take others and take away that execute permission, I could use the symbolic method to achieve that purpose, and go back now and look at the long listing, and indeed the others no longer have execute permission. Okay. So if you're curious as to how this command works or what happens when we use it, we can run now.sh and see that it prints the time right now is, and then 13:38:12, which is the 24-hour clock, and it is indeed 1:38 p.m. Permissions can also be changed using the numeric method, also known as the absolute method. And it is based on an octal numbering system where each permission type is assigned an aggregate value. You can see that read is equivalent to the value 4, write is given the value 2, and execute the value 1. So altogether, we can count from 0 through 7. That's what we can do in octal. Right? So by using a combination of numbers between that range 0 to 7, any possible combination of read, write, and execute can be uniquely specified for the group user, the group owner, or the group others. And you can see in this little chart how each of those numbers would translate into the mask that you see when you do an ls-l command. For an example, you often see read, write, dash, RW dash. That translates to 6, which is 4 for read plus 2 for write. So once you use it a bit, experiment, practice, you will get the hang of it. You can see that you can set the permissions of this file abc.txt to have the mask rwx, r-x, and r-dash by using chmod, the numeric method 754. Okay, let's walk through the background on this. So, if I wanted RWX, that would be read 4 plus 2 write plus 1 execute, or 7. R-X is read of 4 plus execute of 1, or 5. And then for others, read only, leaving us with only 4. Let's see how this applies at our command line. Right now we see that now.sh seems to have all its permissions open for every group and every permission. But say we didn't even know that. We didn't have any awareness of the current permission mask for now.sh. All we've been told is that we want this file to have read, write, and execute permission for the user owner. So that would be 7, right? Read 4 plus 2 plus 1. And read and execute for the group owner. So that would be 4 plus 1, or 5. And then read only for others. So others cannot execute our script. So read-only would be for, right? So how do we combine that into the chmod command? Well, we can just put chmod before that number mask and then add the name of the file, and we will see how we ended up, which is exactly as we've been instructed. Read, write, and execute for the user owner. Read and execute for the group owner, and read only for others. So again, the octal or numeric or absolute method, one of those names, is best applied when you have an understanding and know what mask you want to be the final permission mask without any regard to what exists right now. Whereas the symbolic method is best applied if you know what you want to change about the permissions. And you usually have an understanding of what exists now, and you know what you want to add to or take away from. Both methods are, perfectly legitimate, and some people lean more toward one on more occasions, while others will lean toward the other. I tend to like the numeric method, but again, it's not always appropriate. So you need to, think about what it is you've been asked to do and choose the right method for the task. Again, practice, practice, practice. Experiment and have fun with it and learn.